Yes, guys, thank you so much for joining. I welcome you all over again to this class named Mixture and Allegation. Okay, and before I start this chapter, there's a little bit of background information about this chapter. The one is the amount of effort, the amount of knowledge, the amount of confidence that you have gained from a chapter called Ratio and Proportion. Okay, that will be leveraged over here. Okay, that will be directly proportional towards your confidence building your success in this chapter, right, guys? Okay, and talking a little bit about the question paper as such, and there is not very much prevalence of mixture and allegation, but since you guys will have your examination in 6 different shifts, okay, you can expect one question in any of 2 to 3 shift maximum. Okay, so some of you might face it, some of you might not face it. This is what I mean. Okay, because in 3 days, 6 shifted, all the question papers will be jumbled. Someone solving X question paper may or may not have that question paper. They might have similar, but obviously that's not going to be the same. Okay, so this is what it really it makes it important for us to study, and that's a pretty interesting chapter. Okay, and it kind of disturbs everyone. Okay, when I used to prepare for it, it used to disturb me as well. Okay, and by teaching you and to study all by myself so as to teach you, I become less fearful of this chapter. So let's tackle it. Let's tackle it together, right, guys? So mixture and allegation. Okay, let's understand what exactly do we mean by mixture. Okay, mixture, like some Haldiram, it's a mixture, right? Or some other brand, some sort of murku, isn't it? And all that murku is not mixture, I know, but you will have all that mixing of whatnot, different you know assortments like you will have potato chips in it, sometimes banana chips in it, not banana chips, potato chips, and peanuts in it, and some dal in it and whatnot. Okay, so that is mixture. That is one mixture. Concrete, whenever there is construction happen, they mix concrete with cement. That is also mixture. There's a big machine that will be rolling round. That is also mixture. Okay, and when you go to the shops, okay, so these are all mixture. Basically, a milkman who adds milk with water, that is also mixture, right, guys? So I hope what is mixture, that is clear. Okay. Allegation now. Allegation means what? Okay, I am saying that the other person is guilty. Okay, that is called allegation. And what do I mean by I'm saying other person as guilty? Obviously, the other person would have done something wrong. And what wrong they would have done? Let's say this milkman, he adds water. Okay, so that's his allegation, that he is adding water, that he is not giving us the pure milk. Right? You go to a rice shop. Okay, they sometimes add stone. That's their allegation, that they have added stone. It's not giving you the pure thing. Okay, so these two things are not, should not, or it should not be thought in silos. These two, mixture and allegation, should not be thought in separate terms, right, guys? So in this chapter, this was the basic preliminary talks about the chit chat about this chapter per se. And as far as coming to your examination point of view, whether it is your AFCAT or whether it is XYZ examination, you will be having 3 broad types of questions that people generally encounter. The first one is one vessel problem. Okay, please pardon my spelling and writing. One vessel problem. like something mixture, titration, nitration, allegations, and all whatnot happening from one vessel itself, right? Okay. There'll be two or more vessel problem. And the another one will be your replacement. These are the three broad types of questions that we'll be encountering, right? And we'll be seeing how exactly it's working in the questions that we start. Okay. Though when you go out in public, when you go out in to read from the open sources, you will realize that there's lots and lots of formula. But I'm not a big fan of formula. Big fan. But I've also told you to be what? Unorthodox. Okay. That means we'll not stick with this only. Okay. That means we will not be just so stringent with our thought that we'll not use the formula at all. We'll see how exactly it works out. Okay. So with this, let's start to understand this allegation, what Greek they have written. Allegation, the ratio of the weights of two items mixed will be inversely proportional to the deviation of attributes of these two items from the average attribute of the resultant mixture. Guys, did you get it? Anybody who got it, please come front and tell me what is this. I did not get it. Right? But I got the sense what in the idiotic shit this person is talking over here. Okay. Basically, it's saying that the ratio of the weights of two items mixed will be inversely proportional. Okay. To the deviation of the attributes of these two items from the average attribute of the resultant mixture. Okay. Going ahead, we'll be solving a question with that. Okay. But before that, let me just ask you that, the price, okay, the price of, there are two types of rice. The one is 40 rupees per kg and the another one is 60 rupees per kg. The question is, in what ratio they should be mixed? In what ratio they should be mixed so that their average resultant price is 55 rupees, let's say. Okay. So such type of questions will be solved using this method. Okay. What is this allegation? I do not understand. If you understand it, please tell me. Okay. And I do not want to understand it either. Let's check it out. This is all shit. Okay. Yes, Senthil, good morning. Right. So we check it out, this one. Right, guys? But then it doesn't mean that we will not use this formula. This is your important shit over here. And this is what we'll be using. Right. So far, so good with me. Are you guys good up till here? Shall we move? We'll solve a question based on that. Guys.
Yes, sir.
Yes, sir.
We'll solve a question based on that. Don't worry. And now you have got what I told you. The third type of problem that you will be seeing is your replacement. And to find that replacement, we'll be doing it two ways. One, will be unorthodox and will be orthodox. We'll see what exactly happens. When we be orthodox, we use this formula. Okay. And the formula is that to find the original entity after an operation. Okay. Let's say there's a container of milk. Okay. There's a container of milk. So in that milk, let's say it's 100 liters. Okay. 100 liters. What am I saying is that 5 liters of water is being added. 5 liters of milk is being replaced by the 5 liter of water. Okay. And again, 5 liter of the solution is again, replaced with 5 liters of water. And again, this solution, the resultant solution after 2 processes mixed with, it's replaced with again 5 liters of water. Okay. So in that case, to find the original entity after an operation, like how many iterations happen? 1, 2, 3, 3 times. This was the milk. This was the milk. Milk taken out. I mean, this arrow, right hand side arrow represents milk taken out, water given. Okay. And this happened how many times? 3 times. Right, guys? So to solve the question, I mean, initially it was 100 liter all milk, right? But then this kept on changing, this kept on changing. If we are adding water, obviously, this amount of milk must be decreasing for sure. Right, guys? Must be decreasing for sure. So after these 3 iteration, how much of milk is there? How much of milk is there? To answer this question, we use this formula. Okay. The quantity divided by the quantity of mixture, that is 100. We assumed over here. Okay. And A, where A is the original quantity. If you are not getting it, hold your horse, don't worry, we'll solve this question. Okay. Just trying to explain you the formula. Is equal to, yes, buddy, anybody, any problem? Yes, Abhikaran. Buddy, please mute yourself. Yeah. So where A is the original quantity. Okay, A is the original quantity. We started with 100 liters of milk. And B is the quantity that is replaced. What did I tell you? That it is being replaced 5 liters. Okay, 5 liters of milk is being replaced with water. Okay, divided by A. A is 100. How many times this iteration happened? 3. You find out what is the value of Q. You will get how much of milk is remaining. Right, guys? So as I mentioned to you, to enjoy this chapter, you should have studied ratios and proportion. Okay. Now you will see that how ratio and proportion is helping us in this chapter. Right, guys? So with this, we are almost done with the basic concepts that you are required to study. There is no, basic concept as such per se. Based on this, people might give you some new scenarios and create formulas. Okay, they can divide it in types. That can happen. That can you go and read from the open sources. But my goal over here is to mold your thoughts, and not to go the bookish way, right? Bookish way. Think, connect it with your life. Somebody comes to give milk to you and you realize that that bloody chap has been giving you, adulterating milk. You will feel bad, right? Shall we move, guys? Shall we try to understand these concepts that we have studied in, shall we learn how exactly should we apply? Yes or no? Guys,
Yes, sir.
Yes, sir.
thank you so much. Yes. Yeah, so this is the first question. Okay. How do you want to solve it? Whether you want to use the formula, whether you want to go unorthodox, and you want to go orthodox. That means using formula the conventional. Take your time. It's 5:52. Take your time. Take 2-3 minutes of your time. Don't worry. Okay. At 5:55, I'll explain you. Take your time. And this question is calculation intensive. So don't lose your mind while calculating. Okay. Just calculate it easily. Just be patient and calculate. I'm not going anywhere. I'm here only. So anything, ask me. I'm sure you guys must be doing it with the orthodox method. So a container contains 40 liter of milk. Okay. What we had the formula Q divided by Q means after iteration. A container a container contains 40 liter of milk. From this container, 4 liters of milk were taken out, replaced by water. 4 liter of milk were taken out and water were poured in the container. Okay, this is the 40 liter. Right, guys? 4 liter of milk were taken out and replaced by water. Is this one time that has happened already? And this process was repeated further 2 times. So what is your N over here?
Sir,
3.
option 2,
Who is that?
Ajit Kumar.
Ajit, what's the option you said, buddy?
C.
Okay, we'll evaluate that. That's correct, though. Yeah. Thank you. Thank you so much, Ajit. Yeah.
Yes.
So N is 3 over here. N is 3 right now. Once it has already happened and 2 times it is repeated further. Okay. What formula did we study over here? Q quantity of original entity after N operation or after N iteration divided by quantity of mixture. So Q, we don't know. This is what we need to find, which will be one of these 3 answers. And what is the quantity of mixture? That is 40. Then what is A? A is where A is the original quantity. B is the quantity that is replaced. A is the original quantity. Original quantity how much? 40 liter. And the quantity that is being replaced in each of these iterations divided by 40. How many times? 2 or 3?
3 times.
3 times, yeah, 3 times. Anybody else who did not get it why I'm writing 3 times? All clear? Mateshwaran? Mateshwaran?
Yes, sir.
Yes, buddy, are you with me? I'm just using formula, nothing else. I'm not doing anything. I'm not even applying my mind now. We'll apply our mind over here when we become unorthodox. Right? So Q by 40 is equal to 36 into 36 into 36 divided by 40 into 40 into 40. Any doubt up till here, guys? This 40 will go. 9 and this 10. This 9, this 10. Should we also do one more round of cancellation? No, we don't. We should not, because this will give us 100, right? Or anything divided by 100, we can easily find it out. And what is over here in the numerator? That means Q is equal to 9 into 9, 81 into 36 divided by 100. Look, guys, 2 by 2 multiplication, how to do it in a single line. Okay, first you multiply this. How much is this? 6. First you did this. Okay, then you will do this cross. So 8 into 6, 48, and 3 into 1, 3. 48 plus 3 is 51. That means 1. How much is the carry forward? 5. Then you will do this. How much is this? 24 plus 5. How much is this? 29. This comes out to be your 29.16 divided by 100. Right, guys? And how much is this? 29.16, which is what you were required to find. Guys, am I clear? This is how we do it using the formula. Anybody who did not get it, well, there is nothing to get it. I understand. Okay, we don't have to break our minds over it. We are just using formula. The very idea of being unorthodox is to be flexible in our approach. Okay, so even by saying that we are being unorthodox, essentially we are not. We are open to understand from formula wise as well. Shall I delete this? And let's be in our own little bit of, let's try and understand our way. Milk. How much is that? 40 liters. Okay. 4 liters of milk were taken out and replaced by water. Okay. So after first what happened? Milk and water quantity. If 4 liters were taken out, 36 remaining. 4 liters, this was the pure milk. Now water will be how much? 4. Right, guys? Now it's a second iteration. This is your second iteration. In the second iteration, now the mixture is what? Mixture is milk plus water. Both of these are there. Yes. Both milk and water is there in this iteration, no? Yes or no? Yes,
Yes, sir.
if you say yes, we'll move quickly. We'll cover more number of questions. Right? So, and this milk plus water both will be there. Okay. And 4 liters of this will be removed. So 36 into 4 is to 4. Right now, what is the ratio of milk and water in the container after first iteration? It's this 9:1. 9:1, guys. Right. So when we remove 4 liters, how much of water will be removing? 0.4 liters of water and 3.6 liters of milk. How did we come to these numbers? 4 liters we are removing, guys. 4 liters we are removing, but after the first iteration, it will be milk plus water. Guys, following me. Following me. Okay. So this much of milk will be removed. Okay. This much of milk will be removed. Are we adding any more milk over here? No. So 36 minus 3.6. How much is that? 32.4. Will we have 32.4 liters of milk over here? Right now. And what? The total will be always be 40. Over here will always be 40. So what will be your milk? You can find it two ways. Sorry, what will be your water? You can find it two ways. Either you 40 minus 32.4, how much is that? 7.6. Either you do this way or you see that 0.4 liter of water is going out and 4 liter of water is coming out. So how much is it? 3.6 is added net. Already water was how much? 4 plus 4. How much is that? 7.6. Right, guys? Now, after the third iteration, this will be your ratio. Okay, this will be the ratio in which the solution will be there. Now, yes. So in this one, if it is 32.4 divided by 7.6, this is the ratio of milk and water after the third iteration, after the second iteration. Right, guys? This one gone, this one gone. 162, how much is that? 38, how much is that? 19, how much is that? 81. Okay. Basically, these are into ratio. After the second iteration, the milk and water ratio is 81:19. Right, guys? Okay. So when we remove 4 liters, okay, how much of water will be removed? How much of water will be removed? 19% of 100, 19% of 4 liter, how much will be that? 0.36 liter of water will be removed. Right. but we'll be adding 4 liters of water as well. Right, guys? So 4 minus 0.36, how much is that? 3.64. 3.64 now. So when it comes from here to here, it will get plus 3.64. So let's add it 7.6 over here. So 4, 12, how much is that? 11. Okay. So 11.24 will be your water after the second iteration. Okay. And now if 11.24 is the 11.24 is your water, what did we talked about? That overall it will be 40 over here. So 40 minus 11.24, this will give us the milk. Okay, how much milk is remaining? How much is that? 76 point. Did we do some calculation error, guys? One moment. So that is why because of all these cumbersome steps that we are doing, it is advisable. It is advisable in this replacement type of questions. Please use formula. Right, guys? Let me just check 36.4. Okay, this is after the first iteration. So it is 9 into 1. Okay, 9 into 1. 4 liters. Up till second step, it's okay, right? It's good. And then after this 7.6, what happens that 7.6, it is of the 81-19 ratio. These two are the 81-19 ratio. Guys, can you guys calculate and tell me if this ratio correct? 81-19 that I have found it out here. This and this, okay. 1, 3, 3, 2, 4 divided by 76, 38, 35, 6, 7, 8, 38, 1, 6, 2, 81, 19. That is also correct. Okay. So that means 19% will be removed. 19%. Okay. If we take 4 liters, 4 liters means 19%, 9 into 36. 36 plus 4 is how much? Plus 4 liter of water is there. 0.36. Guys, are you guys able to see some calculation error that I might have made? Okay, let's take it. Let's talk about the milk side. Okay, it's 32.4. One moment. Just give me one moment. Let me erase all this to make some space. Yeah. Don't worry. This is the only question in the entire mixture and allegation that will disturb you. Okay, but if you learn this one, the whole chapter is done. That's it. Post that, all are easy. Okay. So 32.81 no, okay, it's 4 liter of we are removing. We are in the ratio of this is in the ratio of this. If 4 liter is removed from there, what will be the 20% of 4 liters? 20. That's what I was thinking. 20% of 4 liter is 0. Yeah. Guys, look, 19% of 4 liter is 76 and not 36. Guys, okay. So the water that will be removed. Now, after this second iteration, this is the ratio of milk and water into the solution, right, guys? And now, if we remove 4 liter of this solution, how much of water will be removed? Look, if we add these two, this is what? How much? 100. Luckily, it is 100. That's why it's making our calculation a little easy. Otherwise, otherwise we would have to do it in a different way. Okay. So 19 part of 100. Okay, 19 by 100 into 4 liters. Okay. So that means 70, that means 0.76 liter. Guys, do you have any problem? Do you have any problem in understanding this one? This much of water will be removed. I mean, that 4 liter that is we are removing, this much of water will be removing 0.762. No, sorry, 0.76. And how much of milk will be reducing? We'll be reducing this much. How much is that? This is 4, this is 2, and this is 3. Guys, please pay attention to my calculation error if I'm doing any one. Okay. So this much of milk is getting removed from this 4 liter. Okay. And then we'll add water into it. But originally milk was how much? 32.4 liters. And now let's reduce this one from here. How much do we get? 16. Do we have any carry forward? No. 29. Okay. This is what they have asked. At this point, after the 3 iteration, basically this was the second iteration, this was the third iteration. How much of milk is remaining? 29.6 is your answer. Guys, if you got it, it's good. If you did not get it, it's even better. Right? Remember this one, and we are good to go. As far as this question is concerned, particularly. Right, guys? Guys?
Yes, sir.
Cool. Thank you so much. Anybody else, any doubt? Anybody, any doubt? You guys won't have any doubt. Moilan, buddy, you got it? Look, Moilan. The quantity, okay. Let me just erase it to make some space. Look, we are saying that you got a milk, okay, 40 liters of milk. And in that, Moilan, buddy, are you there? So we are saying that 4 liters of this solution is being removed and 4 liter of water is being added. Okay, this is happening one time, then again 4 liter removed, again added plus 4 liters of water, and again 4 liters and 4 liters of water. Right, guys? This is what is happening. So they are asking, earlier it was pure milk. Now it became milk plus water. And now in this one, now we are adding more water. Milk will get even more diluted. Right, guys? So they are asking, what is the value of milk? What is the quantity of milk that is left at this point of view after this 1, 2, and 3 steps? Right, guys? Shall we move? Shall we move, guys? Shall we move to the next question?
Yes, sir.
Cool. Thank you so much. Yeah. I want an answer from Muilan, from Mateshwaran. Yeah, first you to answer, then we'll ask. Yeah, Christy. Yeah. Who is that? In a mixture of 100 liters. Let's draw 100 liters. Okay, what are there? Milk plus water. Okay, sorry, I'm writing 4. What are there? Milk plus water. Okay, and they are in the ratio 4:1. If they are in the ratio 4:1 means what? 80 liters of milk and 20 liters of water. Right? This is M, this is W. 40 liters of mixture is drawn off. This word is very, very important. Read it carefully. Mateshwaran, are you there, buddy? Are you there?
Okay.
Yeah. Read this. Read this. I want you to solve this question. It's not that easy, that tough. Trust me.
40 liters of mixture in oven of
Sorry?
40 liters of mixture drawn off.
Yeah. 40 liter of mixtures drawn off. That means 40 liter of mixture was taken out. Right, Madheshwaran? Find the ratio of water and milk in the remaining mixture. After reducing 40 liters
So
from a mix. Sorry?
is it the same ratio after?
Yeah, absolutely. It will remain the same. We don't have to solve this question. Solving is not required. Mateshwaran, I'm saying that I mixed, milk and water. Okay. I have 100 liters of it. And I'm saying I removed 20 liters from that. Then what will be the ratio of milk and water in the container that I have, that remains with me? This milk that you removed and this milk that is already there or still there, are they not same? Same only, no? Mateshwaran, Hari,
Yes, sir.
try to understand. I mean, you had a container of milk, you removed something from this container, okay, and they are asking what is the ratio of milk over here, okay. This and all, they're just giving it to confuse it. I'm getting from a milk pot, if I remove like let's say from the milk pot, if I remove one liter of milk, then will the ratio of milk and water will change? I mean, assuming that no milkman gives original milk, guys, unless you have a cow in your home, if you buy it, nobody gives the pure one, right? No, Mateshwaran, you got a cow in your home?
Yes, sir.
You got one? Good, yeah.
No, sir. No.
Oh, I got one. My nanny girl. Okay. Anyways, so what am I saying is that water and wine. Okay. Okay, I will not ask you whether you drink or not. Fine, let it be. So water and wine. Okay. You mixed it in a big bottle. Okay, 1 liter bottle. Okay, because you had a party in your home, right? Something like this. And you poured a few glass to your friends. Mateshwaran.
Sir.
Mateshwaran. So you mixed it, with 2 parts of wine and 5 parts of water, let's say. So after giving it to your friends 1, 2, and 3, will it change? It will remain 2:5 only, no?
Yeah.
No, will it not become? It will remain 2:5 only, no? Hmm?
Mhm.
So this is what they're asking. Read the question, easy, easy. Just keep your mind calm and read the question what it is saying. You guys panic. You guys have this preconceived notion that I cannot do maths. And then for that, you have created something called mental barriers for yourself. Okay, mental barriers that this I cannot do. Okay, you should turn it in this I can do. Because those who do it, those who solve it, they are also normal human like you and me. Right, Mateshwar? We are not Abhimanyus. That's in mythology. And there is no proof that mythology is right or wrong. Right? So don't have this mental barrier. Don't give up initially itself. Try to understand. Give it some time. Right, Madheshwaran? Shall we move? Did you get this question? If you do not get this question, the class won't move today.
Yes, sir.
Did you get it?
Yes, sir.
Thank you so much. Yeah, guys. Over to you. Open for the floor. All yours. All those whom I counseled yesterday, they have run away except Mateshwaran. Yeah, I give tough feedbacks. Whether you are a topper, whether you are whichever way you are. Your English ma'am might be soft spoken. I'm not. I'm so sorry.
The option is right.
Okay.
Yes, sir.
Okay. Good morning, Deepthi. Everybody is saying it. Cool. So you don't need to solve the question. Everyone knows it. Okay. So in a mixture of 35 liters, the ratio of milk and water is 4:1. Madheshwaran, look. This is your container. There is 35 liters. Okay. Of milk and water. All of them. Not just Madheshwaran. Every one of them. Okay. Just that yesterday you got a little bit tough feedback from me. All of you get tough feedback only. So in a mixture, 35 liters are there. The ratio of milk and water is 4:1. So Mateshwaran, tell me how much of milk is there. You just tell me this one, I leave you for the rest of the class. I won't disturb you. They are saying in a mixture of 35 liters, the ratio of milk and water is 4:1. 4 parts of milk and 1 part of water. Right? That means milk is how much? 4/5? Mateshwar,
Yes, sir.
into 35. Into 35, when you do 35, that's how we'll find out. No, out of 35, how much of milk is there? What did I teach you? 4/5 means what? 1, 2, 3, 4, 5. 4/5 means this part. Right, buddy? This part. 4/5 means this. Okay, if there are 5 parts of milk, sorry, the whole 4 part is milk and 1 part is water. So out of 35, how much is there? How much of milk is there out of 35 liters? Calculate and tell me how much it is. Yes. How much it is? How much it is?
28.
Yes, 28. Say loud and clear, 28. Come on. You got to go and win the world. And you are just so doubtful about yourself. Seriously. Come on, worry. And how much will be the water?
7.
7. Yeah, absolutely 7. If 7 liters of water is added to the mixture, shall we add to the mixture? That means this 7 will be added here. So how much will be the water?
14.
14. Yeah, absolutely. So what will be the ratio of milk and water in the new mixture? In the new mixture, milk remains the same. Water is this much. Milk and water, it's 28, it's 14. What is the ratio?
Sir, option here.
Option A, 2:1. Did you get it, buddy? Did you get it? How
Yes, sir.
easy was it? Okay. So don't give up the question just by reading it, or don't just give up. Read it. You have to read it 1 times, 2 times, 3 times, 4 times, if required, 5 times. For the first time when you solve questions, it will take you 1 hour, 2 hour, one full entire day. But slowly when you keep solving, this time will keep on reducing and you will start solving in a jiffy. Right, guys? Thank you so much. Thank you so much, Mateshwara. I'm really happy, that you participated. And you just not only participated, you took the entire class to the end of the conclusion to the question. I'm very happy today. Thank you so much. So, yes, okay, over to you. Open for the floor. 2 minutes, solve it. 6:25. I'm not going anywhere. I'm here only. I'm just muting my mic, right?
Sir, option C. Sir, I think you are muted, sir.
Yeah, thank you so much. Anybody who wants to contest this option? This answer
Shruti,
given
sir.
by who is this?
Shruti, sir.
Thank you so much. Who else? Yes, Abhikaran, Christy, Deepthi, Ji Sir Janni, Krishna, Ajit Kumar, Rajesh Khanna, Ranjita, Sandhya, Santil Raja. I cannot call Mateshwaran because he already answered. Yes. Who else do we have over here? Who else do we have? Guys,
Option C.
who is this?
Ajit.
Ajit. Yes, Ajit. Please tell me what was your mindset? What did you think? How did you think about this question? What ran in your mind that you thought that option C 7.7:5 is the answer? Yeah, the answer is correct. Want to know the procedure? What happened, Ajit? Come on.
Sir, copper is 7 by 9 into 100.
Yep.
Gold, sorry sir.
Hmm.
Gold is 7 by 9 into 100. Copper is 2
Mm-hmm.
2 by 9 into 100.
Mm-hmm.
And now 17 by 80. Gold is B 7 by 18 into 100. Copper is 12 by 18 into 100, sir. Gold 700 by 9 plus 700 by 18 equal 2100 by 18, sir.
7 by 18. Okay.
And 200 by 9 plus
Okay.
and
Okay. Yeah, Ajit, got it. Thank you so much. Thank you so much. Thank you so much, buddy. Can anybody? Yes, Abhikran, that answer is correct. Thank you so much. I'll call you. I'll invite you to the class for your discussion in the next question for sure. Anybody can tell me how could I made this calculation, this question easier.
So instead of taking 100, like we will assume it as first 18 gram of alloys.
Yes. Yes, Shraddha. Yes, I got it.
18
Thank you.
gram.
Yes. Yes. Absolutely. Absolutely.
In the first case, if it is 18 gram, can I simply put answers there or it's enough?
Yeah. Yes. Yes, sir. Absolutely. Absolutely. Thank you so much. Thank you so much. So instead of assuming this, Ajit has assumed that A and B are two alloys. Alloy means what? It will be a mixture of more than one metal. Right. Over here, in this case, it is gold plus copper. Prepared by mixing metals in the proportion 7:2. This is your basically alloy. And there are two alloys, A and B. And their ratio is how much? Gold is to copper is 7:2 and 7:11. Right, guys? Right? Okay. No problem, Avikan. Thank you so much for joining. Yeah. So this is the ratio of these two alloys, A and B. This is the ratio of gold and copper respectively into A and B. Right. So instead of assuming 100, instead of assuming it as 100, if we assume, let me delete this 100, one moment. If we assume A and B are two alloys going to be prepared by mixing metals in proportion, if equal quantities of alloys are melted, equal quantities of alloy are melted. These two alloys, okay, this is basically gold proportion, this is basically copper proportion, right? For your A and B. Since they are saying equal quantity, this equal quantity, shall we assume it as some, which is the LCM of this denominator, both of these, it will be easy for us to work around right now. So if we assume it as 18, what will be the gold in it? It will be 14 over here. And it will be how much? It will be 4. Let me highlight it. 4, 14. Over here also, if you do it 18, guys, it's 11 by 18, right? It's 18 over here. 1 second. This gets clumsy. So over here it is 11, over here it is 7. Okay. So what are they saying now? Both of these are mixed. Both of these are mixed. So if though both of them are mixed, what will be your ratio? Equal, both are in equal quantity. Okay. So both of them are 18 grams only. Both of them are 18 grams only. So over here 14 grams of gold, 7 grams of gold, 21 grams of gold is to how much? 4 grams of copper, 11 grams of copper, 15 grams of copper. So how much is this? 7:5. Anybody, any doubt? Guys? Anybody, any doubt, guys? Sure? Shall we move?
Yes, sir.
Shall we move, guys? Yeah. Anybody apart from Shruti? Shall we move? Because these guys know it, so they will obviously say yes. Anybody? Moilan, buddy, you got it? Okay. Thank you so much. Thank you so much for writing in chat. Yeah. Yes. Over to you. Very easy one. Over to you. 1 minute of time. Quickly, let's solve it. So cold over here.
C, sir.
C, sir.
Yes.
Sir, options.
Okay. Who is this?
Sir, Janani.
Janini, where were you up till now? You are solving only the easy questions. Okay, Janini, please tell to the class. So sorry for disturbing your sleep or meditation or whatever was there on that side. I'm sure it must not be the case that you did not know how to solve those. It's just that you might be being lazy, right? So Janini, please tell me what were your thought process? What is the question? It's a mixture. Okay, let me read out the question for you. It's a mixture of 60 liters milk and water. Yes, Avikan, you are correct, buddy. Thank you so much. Is 2 1. So that means milk is 40 and LW. Water is 20. Okay. What amount of water must be added plus what to make the ratio of milk and water 1:2? Yes, this is Janani. Over to you. Tell me what were your mindset? What did you think? How did you
Sir,
think?
to make it as 1:2, the
Hmm.
water must be like the milk must be remain the same.
Yeah.
Sir.
Mhm.
So I have to double the water. So we have to add 20 plus 60. So it will become 80. And if we equate like 40 is to 80, which means 1:2.
Yeah. Thank you so much. Is there any cumbersome concepts that you are using? No. Muilan, Mateshwaran,
Yes, sir.
Krishna. Did you get it?
Yes, sir.
Christy, did you get it, buddy? Christy.
Yes, sir.
Yeah. Absolutely. The ratio of milk and water has to be 1:2. Right. Milk will not change because milk we are not adding. Okay. So if milk and water has to be 1:2, that means if milk is 40, obviously your water will be 80. There is already 20 water in it. That means how much you should add? 60. Right. Tell me it's a question of ratio, proportion, or mixture allegation. So it's that way. Yes. Yes. Good one. Slightly twisted, but it's easy. And this twist is there in the beginning itself.
Sir, option B.
Option B. Who is this?
Sarita, sir.
Are you and Shruti are in agreements that you guys will only speak on one first and second? Huh? Okay. No worries. Thank you so much. Yes, I want at least 5 of you to answer, and then only I'll move. Okay, let me draw something. Let me draw a container that I can do. This is 20 liters. Okay. Contains milk and water. Okay. In the ratio of 5:3. If 4 liter minus 4 liter. Okay. Of this mixture plus 4 liter of milk. The ratio of milk to water. Yes, Christy, no problem. Bye-bye. Have a nice day ahead. Bye-bye.
Thank you, sir.
No problem. So they are saying the ratio of milk to water in the new mixture. Feel the question. Feel the question. Think about it. Feel about it. Try to solve as if it's happening in front of you. You have a 20 liters of milk mixture right there in front of your eyes. Okay, fine. Whatever the ratio is. Somebody took out 4 liters of mixture and then somebody poured 4 liters of milk in it. How will the ratio change? Think about it. Feel it. Yes, guys, we have only one answer till now.
So option B, sir.
Option B. Who is this? Rajesh. Okay. Thank you so much for yesterday, buddy.
Yes, sir.
Yeah. I want 3 more answers. Okay.
Sir, option B.
Okay. You said D. D for delta or B for beta?
No, sir, B, beta.
Okay, cool. Anybody who wishes to contest this? I need 2 more answers. Senthil Raja. I think I never heard from you, buddy. Senthil. Okay. Sir will open his mouth when there is a muhurat for that. Right? How much is that? That must be 9:30 a.m. And we don't talk at that point of time. That's the right time. Right, guys? Okay. I'm having fun, buddy. No hard feelings, right? Guys, 2 more answers. Quick. Quick, quick.
B, sir.
B. Yes. Yes. Malayagan. Okay. He ran away. We get some visitors sometimes. No problem. So, guys, look. Look. Who is this? Yes. Thank you so much. Thank you so much. Look. This is 20 liters. This is milk plus water. Okay. The ratio is 5:3. Just think 4 liters if it is removed. So instead of we finding it over here, how much of milk and water is there at this point of time, after when 4 liters are removed, even then the ratio will remain 5:3 the same, no? Ratio will remain the same. Right. But earlier you had 20 liters of this milk plus water solution. Now you have only 16 liters of milk and water. Right. And this is in the ratio of 5:3. Yes, Moilan, welcome back, buddy. Welcome back. This is 16 liters. That means how much? Milk and water. How much is this? Ratio you know. I have taught you. You must have studied all by yourself. It is 10:6. 10 and 6. Right. And now we are saying it is also replaced by, it is also being added 4 liters of milk. So if we add 4 liters of milk, how much the total milk will become? 14. And how much is the water? It's 6. So 14 is to 6 or 7 is to 3 is your answer. Right, guys? Anybody who did not understand, Muilan, you understood it, buddy?
Yes, sir.
Yes, Jesus. No problem. You can drop off. Thank you so much for joining. Yeah. Thank you so much for joining. Look, Muilan, what they are saying, for you, you missed it. Okay.
Yes, sir.
You just entered the class after dropping off. This is the container in that you have 20 liters milk plus water. They are saying we removed 4 liters from this solution. So we also removed 4 liters. So how much the solution is remaining? From a 20 liter of solution of something XYZ. Milan,
Yes, sir.
from this 20 liter, 4 liters have been removed. So how much is remaining? 20 minus 4? Yeah, 16. Yes, say that 16. 16 liter is remaining. And what is the ratio? Ratio is your 5:3.
5 is 3,
What's
sir.
total? Sorry?
5 is to 3, sir.
Yeah, 5:3. That means how much of milk is there? This is milk and water.
4 liter of milk, sir.
Milk is 10, no?
Yes, sir.
5:3 ratio. That means what? 5/8 into 16. Right? This is what we mean by 5:3. So this is your milk. This is your water. Right?
Yes,
So
sir.
milk is this much, 10,
10
and
liters.
water is how much? Whether you want to find out 16 minus 10 or whether you want to find out 3/8 into 16. Your choice. 6.
Yes, sir.
And it is replaced by 4 liters of milk as well. They are also adding milk. So this 10 becomes plus 4. How much? 14.
14, sir.
So how much is the milk with you? This much.
14, sir.
And how much is water with you?
6, sir.
So how much is the ratio?
7 is to 3, sir.
Absolutely. You got it, buddy.
Yes, sir.
Thank you so much. Shall we move?
Yes,
Shall
sir.
we move, buddy? Thank you so much. Thank you so much, Moiran. No disturbances from my side for today. You can have your very good night's sleep or meditation or whatever. Okay. Or you might go to your college fest and take care of that also. Yeah,
So,
at
no,
least.
sir. I'm
Okay,
I mean, continue, sir.
okay. Cool. No problem. 72. I mean, not this is next question. It's not the 72nd question. Yes, over to you guys. It's a question of allegation. What I said to you, allegation. Somebody is saying that, hey man, you are cheating. That's an allegation. Okay. So this chap, the shopkeeper is also cheating. Instead of saying 1000 grams or 1 kilogram, he's giving how much? 900 grams. So it's a question of profit and loss. We have already studied profit and loss, and it's a question of allegation. Okay.
Option B, sir.
Yes, that's correct. Who is this?
Harita, sir.
Anybody other than Harita, guys. I leave you early if you guys do quick. We don't have
B,
so
sir.
many times. Sorry?
B, sir.
3 more answers I want, but I will call you onto the floor to ask what is your thought process, right? Okay, thank you so much. Avikaran, you can write in group message. No problem. Okay. Others will also see. No problem. Yes. Nobody else? Rajesh, is he here or gone?
Sir, I'm there.
Ajit? Okay. Ajit. Ajit. Ajit Kumar. Okay, till then, till you guys, till at least two of you answer, I will read. A dishonest shopkeeper professes to sell his groceries at his cost price, but uses a false weight of 900 grams for each kilogram. Look, it's a false weight. Don't think in terms, okay, it's a false weight type of question. What are formula? What? How should we think? No. Do not airtight yourself with this false weight or something like that. Keep yourself free. Okay, movement should be free. Okay, if you have ever, rode a bike, there will be some bikes whose handles will be very messy, okay, very tight. It's not. It's very cumbersome to maneuver those sort of bikes, those sort of cars even. Okay, but no, when you grease it, when it moves right and left pretty quickly, it's very easy to work around with that sort of bike, right? Yes, guys. He says at his cost price. Okay, let's say he's saying selling sugar. Okay, and he bought sugar for 100 rupees per kg. Right, guys? His cost price is how much? 100 rupees. Right, guys? For how much? For 1000 grams. For 1000 grams. And now let's look it carefully. His selling aspect of it. He sold 900 grams, 400 rupees. Are you with me? Anybody who did not get it, please ask. Please ask. Since this person is dishonest, but he buys and he says that I'm selling in the price that I bought. What he is doing that, okay, fine, he is selling for 100 rupees only. But instead of selling 1000 grams that he bought for 100 rupees, he is now giving 900 grams only. So he sold 900 grams for 100 rupees. So he will sell 1 gram for how much? 100 by 900 rupees. So he actually bought 1000 grams, that is 1 kg. So he will sell 1000 into 1000 grams into how much? 100 divided by 900 into 1, 2, 3. He will sell at this rupee. Right? 1000 by 9 he will sell at. And how much did he buy for? He bought for. Now we are selling. Now we need to equate, unless otherwise we equate cost price of 1000 grams, that is 100 rupees, and selling price of 1000 grams, which is how much? 1000 by 9. This is the selling price. This is the cost price. What is his profit? His profit is selling price divided by cost price. I mean, you sold it for, okay, over here it is 100, not 1000. One moment. I mean, you bought something for 100 rupees and you sold somebody to 120 rupees. Obviously, 20 rupees is a profit. This is what we are doing. Selling price minus cost price. That means we are finding the profit. Okay. How much is that? How much is that? This is, again, I'm writing 1000. One moment. Okay. What did I tell you? To match the denominators into 9, both upper and lower. Okay, numerator and denominator. So how much is that? 100 by 9 is the profit that he gets. Okay. And out of how much he gets? He gets out of 100 rupees. Okay. Luckily, this is already 100. Okay. So what will be your profit percentage? This number itself. This number itself will be your profit percentage. Right, guys? 100 by 9 will be your profit percentage. I'm sure a few of you did not understand. Muilan, Mateshwaran, did you
Yes, sir.
understand?
Yes,
Did
sir.
you
Understood.
understand? Sure. Okay. So what I told you that we will be unorthodox. Unorthodox. So let's find, is there another way as well? Okay. He bought 1000 grams. Okay. We don't know how much grams he bought actually. Okay. He sold 900 grams. Okay. For 1000 grams. Okay. I mean, he sold 900 grams. Okay. But in actually, he was supposed to sell 1000 grams. I mean, each kilogram. Okay. That means by selling 900 grams, he saved how much? 100 grams he saved? 100 grams he saved or not? Yes or no? Guys.
Yes, sir.
And this 100 grams that he has saved is out of how much? It's 900 or 1000. Tell me. In such type of question, in denominator, we use the unit of the amount that is being sold. What is that unit? 900. Okay. 900. Right now. So this is his profit. Okay. He saved 100 grams out of 900 grams. So how much percentage is that? Into 100. When we do into 100, that's his profit, no? Because 100 by 900 is what? He is getting 1 out of 9, out of 1 out of 9 profit he is generating. So if this fraction needs to be converted into what? Percentage. So we multiply by 100, no? And when a percentage is to be converted into fraction, it has to be multiplied by 1 by 100, or it has to be divided by 100 in simple terms. Right, guys? How much is this? This gone, this gone. 100 by 9. Okay. If you want to use formula, this is the way to go for this question. Right, guys? Right?
Yes, sir.
Shall we move?
Yes, sir.
Shall we move? This question will be your HW. Okay. Homework. The only thing I wanted to tell you that we don't know quantity. Read the question. And we will have to assume quantity as X and Y. And then you will find a relation in X and Y, and we'll discuss that. Right, guys? And it's not tough either. The only thing in that the previous question wherein Rajesh or I don't know whether it was Ajit, yeah. Ajit, he assumed 100 and I assumed 18. At that particular point itself, we have to assume X and Y. That's it. And I cannot give more hint than this. Okay? Shall we move? We'll discuss this, don't worry. Nope, Avikar, the answer is not 2:3. Answer is cannot be determined. No problem. You do this as a homework and then we'll sit and do it together sometimes, okay? Whenever we sit again, whenever your dot session and all, whenever it comes, okay? Right? Till then, sit with this question and think about it, okay? I'll give you more hint. There are two containers containing milk and water in the ratio 1:4 and 3:2 respectively. There they have given milk and water 1:4 and milk plus water and 3:2. Right, guys? Right. And both of these are container mixed into the third big container like this. So what is the ratio over here they're asking? Of milk plus water. Okay. Since we don't know how much is the quantity over here, we don't know. Over here also we don't know what is the quantity. We'll have to assume X. Or before assuming, there is 1 out of 5 part is milk. Right. And over here, 3 out of 5 part is milk. And 2 out of 5 part is your water. And 4 out of 5 part is your water. Since we don't know what is that quantity, let's assume the quantity in first container Q1 is X liter. Q2 is Y liter. So how much will be the milk? This X. How much will be the water? In first container 4X. Now in the second container 3Y plus 2Y. Now when we add this milk by water, in the first container how much is the milk? X by 5 plus in the second container how much is the milk? 3Y divided by 5. And how much is the water in first container? 4X by 5 plus how much water is there in the second container? 2Y by 5. Let me erase mumbo jumbos here. Okay, cool. Now you calculate this, you will get a relation in X and Y, and that will be your answer. Am I clear, guys? Am I clear?
Yes, sir.
Vikaran ran away. He gave answer 2:1. Come on, buddy. Okay, he was traveling. No problem. How much is the time, guys? 7:03. Let's do a couple of more questions. Okay, let's see which ones we can do. Yep. Sorry. Yeah, tell me.
I think it's already solved one.
Yes, it's already solved. Solve it again. The purpose of me including this question over here is to show you the importance of question paper, the previous year question paper. Okay, many a times they do not even change the values. Leave the question type, pattern, XYZ, whatnot shit. Okay, that paper I picked up from a different year, and this paper I picked up from a different year. This is the importance of previous year question paper. Right, guys? So you have to be very, very thorough with it. And that's why I help you guys with the previous year question papers. Right? So in a mixture of 35 liters, the ratio of milk is 4:1. 4:1 is how much? 28 plus 7. Mateshwaran, buddy. Such an easy question. Even Mateshwaran doesn't want to study. Right, Mateshwaran? Shall we check it? Then just tick this and move. Was it? This one was the answer. Guys, 28-7.
Yes, sir.
Yes. Thank you so much. Yes, buddy. Yes, Abhikaran. It's the same question, but you missed the crucial part that I just mentioned. No problem. You are traveling, I know. Look, these two questions I have taken from two different AFCAT papers, Okay. And that means your question repeats ditto as it is without even changing the values, these idiotic values over here, right? And this is not once, I have done it twice, thrice, 4 times. It's just that earlier we did not have much of a time to reach on these questions, right? So let's move. Thank you so much. Let's solve it. Yep. Tell me, is it a surprise? Shall we move?
Yes, sir.
Cool. Anybody who did not get it. It's the same question that we solved. Same question we solved. These guys don't even change the values. This much lazy they are. I mean, I'm joking. They are not. Okay. Shall we move, guys?
Yes, sir.
Or if anybody has any doubt. Moilan, we solved this question, buddy. Right? We have solved this question already. Or quickly, let me tell you, 60 liters mixture is there. 2:1 milk plus water. That means this is 40, this is 20. Okay. To make it 1:2. So this will always remain 1. To make it 2, it will has to become 80. So that means how much you are adding? 60. Moilan, that's it. That's it is the question, your answer. Next. Yeah. As I told to you, this idiotic looking, one moment, this idiotic looking concept, first term, second term, quantity, quality, and whatnot. Okay, this is what, using this, you have to solve this. Or there's other ways to solve this as well. Okay, but using this method, I want you guys to solve. Okay.
Option B, sir.
Yep, that's correct, buddy. Who is that?
Sir, Harita.
Yes, Harita. What did you think? How did you think? Please help me. Please help the class.
I applied in that the first formula, sir.
What is that first formula?
The shown in first slide, sir. Like select price of two types and the average one and subtracted from both the sides.
You guys, in average, we studied something called, if we take any random data from 10 to 30, let's assume this number, on any given day, the average, the mean cannot be less than 10 or more than 30, right?
Yes.
So, in what ratio should tea worth 10 rupees per kg be mixed with tea worth 14 rupees per kg? 10 rupees per kg. Okay. 14 rupees per kg. This is the rate they have given. Okay. So if we find some average, and what average, what is the weight of this average? This is called weightage average. Okay. What is the weight of this average? We don't know. This is exactly what we need to find, the weight of this. Okay. The ratio, in other terms, in other name, ratio. Okay. In what ratio they should be mixed so that the average price of the mixture may be 11 rupees per kg. Okay. Let's go back and understand. Okay. Let's go back and understand a few of the words over here. I just crossed it. Okay. But yeah, unless otherwise we clear this doubt, it will always eat up our mind. We cannot run away. That's the problem. Okay. So the ratio of the weights of two items. Do we have two items? Do we have two items? Yes, we have two items. One is the T1 at 10 rupees per kg. Another one is T2 at 14 rupees per kg. Right. Let's evaluate. Mixed will be inversely proportional to the deviation of attributes of these two items. Attributes means qualities. Okay, the values from the average attribute. This is your average attribute. This is your average attribute. Okay, they've already given. You say it average or average attribute. Do not complicate it. The words, all these, terms and all are not important. Okay. What is the deviation? Deviation from T, it's 11 and 14. What is the deviation? 3. And why we are crisscrossing it? Because it's inverse. Okay. Where is it? Okay. From two items, inversely proportional. Okay. Inversely proportional to the deviation of attributes. Okay. Why did we not? Why are we doing it like this? Okay. So as to write the deviation as how much is that? Okay. And why instead of 10, 14, 11, why not just doing like this? It's 3 and it's 3. Why are we not doing this? Okay. Right now. The answer is 3:1. Yes. But that is the relation that they have given. Okay. Allegation. Allegation is also a kind of mixture only, apart from the ones that I said to you. Okay. That is also called adulteration as well. Okay, mixing, something like that. The ratio of the weights of two items mixed will be inversely proportional, to the deviation of attributes of these two items from the average attributes of this resultant mixture. So what is deviation over here? This deviation that we are saying, no, this difference 14 minus 1. Difference when we say 11 minus 14 is equal to 14 minus 11, which is what? This is your absolute value, whether it is 3 or 3 minus 3. Right, guys? So this 3 is your deviation. So deviation and inversely proportional of this deviation. How much is the answer? 3:1. Right, guys? Is it 3:1, guys?
Yes, sir.
Cool. Thank you so much. Before we move to the next question, let us suppose this doesn't strike me. Okay, this doesn't strike me that it has to be done crisscross and things like that. So what will we do? 10 kg, 14 kg. Okay. Average they have given 11. So we'll assume 10 kg quantity is X. 14 rupees per kg quantity is Y. Okay. So cost will be how much? 10x plus over here cost will be how much? 14y. And what will be the total cost? 11 into x plus y. Right, guys? Anybody has any doubts and queries with this equation? How did we come to this equation? Guys, they are saying rupees per kg, 14 rupees per kg. Resultant, it average 11 rupees per kg. We have just assumed. Why we have assumed x and y? Because we want to find out the ratio. Want to find out the ratio, and ratio is always in terms of x and y, so that we can denote it in the form of x by y, x is to y. Anybody got any problem, any doubts, any queries into this? Tell me now or never. But yeah, you can tell me in doubt session as well. But tell me now. Any problem, guys? So 10x plus 14y is equal to 11x, sorry. So this is x. Do not want to use eraser yet. 11x plus 11y. Let's keep all the x's, all the y, all the same time. So 14y minus 11y is equal to 11x minus 10x, which is nothing but 3y is equal to x. We want to find out the value of, how much is this? If 3y is equal to x, so if we take this one down, so how much will it be? 3 is equal to x by y, which is nothing but your 3 is equal to 1. Can we write it as 1? Guys,
Yes, sir.
guys, so if you know this criss-cross thing, it will help you. If you don't know it, use what? Logic. Be what? Unorthodox. Right, guys? Shall we move? Shall we move to the last question for the day and for your mathematics concept classes? You guys wanted to study concept wise. Okay. So now we are done with this. Yes, over to you. Take your time. 1 minute, 2 minutes. Take 2 minutes of your time. I'll just take a small 1 minute of break. Meanwhile, you guys solve it. I'm listening to you, but I won't be able to reply back. Okay? Just coming in 1 minute. Right, guys? And let me tell you whom I want to. Yes, I want Ranjita to answer this question. Yes, that's it. Nobody else will answer. Yes, Shruti, thank you so much for joining. Bye-bye. Yes, Ranjita, did you get any breakthrough? Pari? Pari? Pari, it's $1 million question. Okay. Let's have a KBC question. Where is from Ranjita? Option A, Coimbatore. Option B, Cuddalore. Option C, Madurai. Option D, Chennai. It's $1 million question, guys. Call a friend and ask Ranjita. It's $1 million question, guys. Yes. No problem, Ranjita. I know many of you feel shy. No problem. But yeah, I did not want to lose my $1 million. I'm sad about it. A mixture of 40 liters of milk and water contains 10% of water. So 40 liter is that. 10% of water. Any problem, Mateshwar and Muilan, in finding what is the 10% of 40? Why 10? Yeah, let's just put a point over here. That's it. 10% gone. One from the right hand side, just one digit, remove it. That's your 10%. Okay. So milk is 36 and water is 4. How much water should be added to this mixture so that the new mixture contains 20% of water? Yes. If we add some water over here, let's say X, new mixture will have 80%, 20% water. That means what? 80% your milk, isn't it? So if we don't know what is the new solution, so it is what? X of 80%, milk will remain the same. Guys, milk will remain the same, no? Yeah, 36. That means 80x by 100, 36. So cold over here, guys. That means you will have 45 liters. And what is this 45 liters? 45 liters will be the entire volume of your new mixture. Right, guys? So out of this, 36 is water. 36 is milk. So how much is water? 9. 9 is water. But earlier, how much there were water? 4. 4, no? How much did we add?
5 liters.
5 liters. Yeah, 5 liters we add. So what is the answer? 5 liters. Right, guys? So with this, we came to an end of your numeric ability syllabus, concept-wise per se. But we'll keep meeting, and we have another assignment to tackle the evening as well. Take a day of rest, communicate to your friends that tomorrow you won't have your classes from my side. And from next day onwards, we'll start our reasoning, right? Bye, guys. Thank you so much for joining. Thank you so much for your time. Have a great day ahead. Bye-bye. Jai Hind. Yeah.
Thank
Thank you,
sir.
sir.
Thank you, sir.